We saw previously that the vertex shader program has access to this constant buffer that's got matrices in it that we use to transform and project each vertex. But how does the app make the vertex shader program aware of this constant buffer, and how does the app update the fields in there? That's what we'll look at in this video. Over on the app side, we define this structure with these three members inside it, and these are 4x4 matrices. This is a DirectX type from one of the headers. This one's in DirectX math.header, so we can use these types straight from the SDK. Inside DFC scene base, inside the actual scene base class, we have an instance of that same type, there. This is where the app's going to store the data for the buffer, and then at some point we have to copy that over into the pipeline, into the vertex shader, and we do that through this buffer smart pointer. Let's see how we initialize that. So over in the scene base class, in do window independent setup, we have a few lines of code that get that buffer set up. So we start with this standard buffer description structure that we've used before. We take the size of an instance of that data type, that thing, and that's going to be the size of the buffer. It's just one of those. We say that this buffer is describing a constant buffer, but we say that the usage is dynamic, which means that the buffer is going to be read-only from the GPU's point of view and write-only from the CPU's point of view. And then, even though we've said that the CPU will only be able to write to it, which is implied by that flag, we still have to be explicit and essentially say the same thing again. Say that the CPU is only going to be writing to this buffer. So then, having described the buffer, we can then pass that description on to a call to create buffer. We've called this before a few times. It's on the device. We say create buffer, here's the description, give me back a smart pointer to the buffer that you create for me. And then finally we use that smart pointer there to actually tell the vertex shader this is one of your constant buffers. It's the only constant buffer in this case. We can use this API to set an array of constant buffers, but here we're just going to set one. So what we've done is we've made a buffer that's the right size and shape, and we've told the vertex shader about this thing. And now essentially we've connected up the app to this declaration here, this definition here. The name of this and the name of its fields don't have to match this thing. It's really just positional. It's the first buffer in the vertex shader that we're going to hook up to, and as long as it's binary compatible, we'll be good. So we've seen how to get a hold of that smart pointer, and we'll be using that later to actually update the values. So now let's look at this data member and how we update that. You can tell these two apart because this one's got the word data at the end, and that's the actual data itself. The pointer to the buffer doesn't have the word data at the end. So this is the thing we're going to look at. We'll look at how we update these three fields. So one place is in update view matrix. This is where we update the view field of that data member. Talking about updating the camera's position and camera manipulation, and responding to various input from the user, is at least a video, maybe even a whole playlist. So for now, we'll just say that the view base has these three data members that represent where the camera is and where it's looking, and then we call this DirectX API to make us a view matrix based on that information, and we're specifically asking for a right-hand coordinate system matrix. So we get that, we put it inside the view field, so that's the view piece. for the projection piece, we want to look in window dependent setup, because this projection depends on properties of the window. So first thing we do is we get a perspective matrix, and again it's a DirectX API call, right hand coordinate system. The perspective matrix is a function of the field of view, the shape of the screen, aspect ratio, and the near and far planes, near and far z planes. So we get the perspective matrix, we grab an orientation matrix depending which way the device is being held up, and then we multiply those two together and we put that inside the projection field of that thing. So now we've covered projection and the view. Let's look at the world piece. So the world is updated in the mesh render function, because of course the world, out of those three fields, it's the world one that's specific to the mesh. The other two are shared by all meshes. So in the meshes render function, we have this line of code that assigns the world transform member into the world field of that buffer member. So where's that come from? World transform. Have a quick look at that. So it's a member of the mesh base, and it's updated every time we call set rotation, scaling, or translate. We update a copy of a member, and then we call this update world transform function each time, which is up here. And what we're doing is we're taking those members that we updated in the calls down here and calling DirectX APIs to actually make us matrices based on those values. So we get the scaling, rotation, and translation matrix, and then we multiply them together in a particular order: scaling times rotation, and then the result of that times translation. And then we store that away using this API. We store it away in that world transform that we just looked at. So there's the world transform. Copy that in here. So now we've got all three fields updated for this frame, and we're ready to update the pipeline, pass that data along to the pipeline, so that those values will show up in the vertex shader. So how do we do that? And that's these lines of code here that we'll just have a quick look at now. So we're declaring this sub-resource that we're going to use to gain access to the buffer. But the first thing we do is we ask the pipeline, which is represented by the context smart pointer, to map a sub-resource for us, or to map a resource. So this is that buffer smart pointer from here, and we're saying, okay, use that thing, map it into this sub-resource object here. So that maps it, that gives us access to the information. And then we do just a simple mem copy, and we're copying from that instance that we just updated the values of into the sub-resource, into the p data of that sub-resource, the p data member. And the size, the number of bytes that we're copying, is the size of that buffer. So as soon as we've grabbed the resource, by mapping it, we've updated it by copying bytes, we finally just unmap, just to release our hold on that sub-resource, so that we're done with it now, and the vertex shader program is free to start reading that stuff for each vertex, this frame.